Okay, good morning, ladies and gentlemen. It's my pleasure to be able to talk to you for next 25 minutes and hopefully give you some good insights into how my company thinks of modern threats and what we have built to compete, to fight these threats. This presentation is not really technical. I was trying to do more of introduction. So in case you would like to know a bit more deeply technical, I would like to invite you to our booth, which is just opposite the Costa Cafe when you are entering this area. And we have some demo setup. We have computers with everything running, and I will be glad to demonstrate all the technology on live data directly on that stand. Few words about company Palo Alto Networks. We are quite a new company on the market. We were established in year 2005. And since that product launch, which was 2 years later, the company kept growing. And year to year, numbers are quite amazing compared to the industry. Currently, we still are quite small. You can see 1,300 employees are worldwide. Actually, this number is a bit old, so now we are roughly 1,800 people in total. I am based in Prague, Czech Republic, and I'm taking care of the whole Eastern Europe. So Hungary is one of my markets, and I'm glad again to be here. Then I will go into the ways how it is working. Let's spend few minutes on what are we fighting against. The main threat of today's is basically a targeted attack. Attackers want to get sensitive data. They want to get whatever valuable might be in your computers. And the ways how they get into the networks are developing quite rapidly, and they are changing. On this picture, you can see comparison of how they did it in past 10-15 years. It was quite simple approach. They used simple tools which required basically very skilled people. You had to know a lot of coding, you had to know a lot of command lines in order to successfully attack foreign system. Today, the situation is very different. You can buy all of these tools on free market. You can get even hacker, attacker as a service, and you just pay some money and you get the result. These people are very sophisticated. They use technologies which are common in high-tech IT industry, so they keep using encryption, they keep using many evasive technologies. And for security guys, nowadays it's much more difficult to detect that attack is going on and what kind of data this attacker is trying to steal from the network. Plus there is one big challenge, and that's the growth of the data and IT environments becoming more complex. I have two numbers from Gartner. They are saying that in Internet of Things, in 2017, roughly 20% of enterprises will have dedicated security services, taking care just of Internet of Things. Second number is related to mobility. Currently, on your mobile device, if it's used for company collaboration or accessing your emails, currently it's 4% of the data which is accessed by employees in the enterprise. Gartner estimates that in 2018 this number will go up to 25%. And it's quite likely that with today's technology we cannot really efficiently safeguard this data going from the mobile directly to cloud. So Internet of Things, rapid growth, and mobility connected directly to cloud are two big challenges which I think today's security firewalls and other things cannot really compete in a good way with. Let's see how these attackers are working. This diagram is actually not that new because the basic attack methodology is for, let's say, 2-3 years quite stable. If they get a new job, if they get hired to attack a certain target and get certain data out of it, they usually do exactly the same. They somehow try to breach the perimeter, which means either by spear phishing or some other targeted social attack, they deliver this first piece of code into the network of the victim, usually using some simple vulnerability like Adobe Acrobat, Office document, or whatever else, and get first computer infected inside of that victim's network. Then this first computer will start downloading malware from outside internet, means specially crafted piece of software which is usually difficult to detect, but which will get the attacker chances to better explore this environment and find the data which they are looking for. That's next phase. They will start looking around this network environment. They will find out database servers. They will find the storages of the data which they came for. They will exfiltrate the data. They will take it from the servers. Usually they will also encrypt it and then prepare it for export to Command and Conquer server, or basically to the outside world. And that's it. The result of this attack is obvious. The attacker got what he wanted. He has the sensitive and valuable data from the network of the victim. Good news for the security guys is that whenever we stop at least one of these steps, we succeeded. This attacker must have really everything very smoothly going, everything must work, and only if he succeeds in all of these 6 steps, then he succeeded with the stealing of the data. So that's a good chance for us, and actually that's one of the targets that we are going for, and that's how we trying to prevent it. So if I summarize the requirements, what basically this new approach for stopping advanced persistent threats, and maybe one note on persistent. This whole chain of 6 steps can take even many months. We have seen cases when this attack took like 2 years from first infection till the final extraction of the data. So if we want to be successful, we should really focus on attacks which are completely new, because it's not difficult to create a piece of attack code which is unique, which no one has seen. We should focus on all users and applications, including areas which are currently usually not covered, means virtualization and mobility, mobile phones, mobile devices. We should control both network, not only perimeter, but also data center network and network between the clients and servers. And we should focus on endpoints, because whatever goes into the network finally will attack endpoints. And number 4, rapid analysis. I think that's very, very important, because I think we cannot afford waiting for the results of analysis for a couple of days. That's today's standard in industry. If you take like classical antivirus definitions, usually it takes some hours for the definitions to be developed, tested, and then distributed. And this gives to attackers too big window for their success. So this is approach of Palo Alto networks. We have created this triangle, and basically this is the majority of what we are doing today. So if we start with the firewall, that's the strongest item, part of this triangle at this moment. That's something what basically understands of what's going on in the network. It's extensible, it's very fast, scalable, and I will talk more about it in next 2 slides. What makes us different? On this graph, you can see what happens if you take your classical, traditional, stateful packet firewall and you start turning on the security features on it. Because usually it uses a single operating system with single CPU. This single CPU will start doing more and more security tasks, and the total throughput of this classical traditional firewall goes down. So that's the reason why people need to buy 4 or 5 times stronger firewalls than they actually need, because if they want to turn the security on, they know beforehand and the throughput will go down. So in our insides of the firewall, which Palo Alto created on just green field, so to say, in that 2005, we focused mainly on this. We focused on 2 things: on throughput, on the performance, and then on the security. And that's how we work from inside. So you can see that we are using actually two planes, like 2 motherboards inside of each firewall. We are talking about hardware appliances here, but similar structure you can find also in our virtualized boxes, which are working on the same principle. And these 2 planes, we call it control plane and data plane, are completely independent. Means you have, as a firewall administrator or security guy, you have your control plane with your CPU completely just for yourself. So even under heavy load, even under denial of service attack, you can still control your firewall, you can still connect to log files and see what's going on, and probably change the policies and make sure that this attack will soon be stopped. Data plane, it uses multiple cores of CPUs, and also it uses specialized hardware devices, field programmable gate arrays, which is little integrated circuits. Actually, they are not little, they are like quite nicely sized. And they are having specialized hardware inside, so that all of this processing which is needed for threat detection is done very quickly. Very quickly means that we do everything in parallel. Means when packet enters the firewall, all of this processing is done in a streamway base. Means there is no buffering on the disk. All the policies, matches, all identification of applications and users, content, it's done in a single pass. That's why it is so fast. 3 main stones from which we built the security are these 3: application ID, user ID, and content ID. With the first one, application ID, we are able to identify any application which is coming into the firewall. That's what makes the next generation firewall the next generation. We also can still handle IP addresses of source and destination. We still can play with ports and these traditional mechanisms of regulating traffic on layer 3 and layer 4 of OSI model. But App ID allows us to bind the security directly to application. It means that whoever tries to bypass the firewall and, for example, uses this port 80, which is HTTP, and which quite likely will be open in every environment for, let's say, sending out the data. With with UpID technology, we will identify it immediately in first few packets, and then we will able to apply the restriction policies on that kind of traffic. User ID, that's something which adds the dimension of users. We can apply policies to users and to groups of users, not to individual IP addresses. And also in log files you will see real names, not just some numbers. And all the security is happening in Content ID section. It means scanning the content for vulnerabilities, for antivirus signatures, and whatever else might be important from the security point of view. Again, it is happening while the packets are being shifted through the firewall in a stream way. That's the result of these two technologies. Traditional firewalls, they have only this one switch. Turn it on or turn it off, being this application or being it some kind of traffic. With next generation firewall, you can really fine-tune it. You can safely enable all your applications selectively for different users or user groups. That's the main difference. Number two in our magic triangle is next generation threat cloud. That's a service which is hosted somewhere in the internet and basically allows us to very quickly analyze all the unknown, all the new things, new files which no one has yet seen and which are potentially malicious. We are doing it in this way. Basically, whenever a firewall catches a file in transit which it cannot categorize by hashing it and looking up in some database, it sends the file to the cloud service. In that cloud service, there is a big pool of virtual machines which are running basic operating systems like Windows 7 or Windows 2012 server. And these virtual machines are having normal applications which we know that attacker will try to use and attack. And we kind of observe from outside how this file behaves inside of this virtual machine, and we detect all bad behavior. So we know that it is malicious or not. If it's a file which, for example, tries to connect to a well-known command and conquer server, or it tries to open some network connection and upload some files from that computer, we know it's rather be blocked. This system is very, very efficient and very precise. Here you can see some statistics of how quickly it's working, and basically every day each of our firewalls reports us in average 2.5 files which are malicious and yet unknown. It means no antivirus vendor have the signatures for this new threat. At the moment we get it and we analyze it. And very good number is also the last one on that text, which is 6 minutes. 6 minutes is average time for the virtual machine to fully analyze unknown file. In the last 2-3 months, we started to integrate also endpoint protection. Just very briefly on this topic, we believe that this is really needed, that vulnerabilities on endpoint will be there forever, because whoever writes software, it's very difficult for them to write it without any bugs. But instead of focusing on describing all of these vulnerabilities, which you can see here and which are endless, countless, we decided to go for looking for ways how people are actually exploiting these vulnerabilities. And these exploit techniques you can count. We counted them and we came up with a number roughly around 80, 90 different technologies which attackers are using. And we have basically integrated the knowledge of these technologies into the endpoint client. This endpoint client, it's a very small piece of code. Installation media is roughly 20 megabytes. It doesn't consume almost any CPU. It doesn't consume almost any memory. And all what it does is basically whenever you load file into memory of the client, this client attaches small DLL file on the side. And this small DLL then inspects the behavior of the file, what it gets from operating system, what it tries to use from the operating system. And whenever one of these 80, 90 evasion attack techniques is used, we stop it. This client is very promising. It's working actually. And I think it very nicely completes this circle of approach against attacks. One last slide for me, and that's about our partners. We, as a modern next generation firewall, are quite easy to integrate with. I have put only 3 names which I have recently been in contact with, but I think all 3 of them generate very nice value add-on. With Splunk, we integrate in a form of simple plugin. Basically, you enable a component inside of the Splunk environment, and all the log files are then processed by this engine. And you can see, even though it's very small, then in real time you can observe the behavior of the firewall with all the statistics, interface throughputs, and even geographical projection of the data traffic. With extreme networks, the integration is also quite easy to do. The result, what you will get, is that in the network you can control even different network devices, not only the main firewall, and tied this control with the user identity. If you would like to know a bit more, I can suggest to you at 1:20 today in room number 13 there will be a session talking about extreme networks. And VMware, I have added them because there is a quite fresh product which is a virtual firewall which can be installed on VMware NSX. And what's different compared to the traditional NSX approach is that whatever you have seen on app ID, user ID, and the high security controls, now you can seamlessly do it in big data centers. Very easy. Nicely integrated and again, working nice. So that's it. Thank you for these 25 minutes we have spent together. And again, if you want to see more, talk to us, please come to our booth, which is here across Costa Cafe. Thank you.